Students, we're going to talk about two important concepts in data communication. The first one is data representation, and the second one is data flow. Students, how the data is represented decides on how we are going to communicate it. We are going to send it from point A to point B, from the source to the destination. Students, as already introduced to you, data can take multiple forms. Your data can be text. Your data can consist of numbers. It can be a picture. It can be audio, or it can be a video. Now, students, going through each one of these one by one, in the case of text, we represent the text, or we communicate the text from point A to point B in the form of bit patterns. Every single character, every single symbol is represented by a particular bit pattern. We say that that bit pattern is actually the code for that particular letter, for that particular character, for that particular symbol. Students, ये bit pattern हम लोग transmit करते हैं from point A to point B using a system of code which is called as Unicode. Students, Unicode is a 32-bit coding system that we use to code every single character and every single symbol. This Unicode, it actually comes from our ASCII standards of coding, and it governs how we communicate, how we transmit, how we convert every single character into a bit pattern or a code, then get transmitted from point A to point B. Students, then we have got numbers. Once again, numbers are also represented by the bit pattern. It's just that the numbers get converted directly from a number form to a bit pattern. There is no Unicode that we use to convert a number into a bit pattern. Binary system, से अगर आप familiar हो, तो you will know that how we directly convert a number into a bit pattern. Students, coming to the picture consists of pixels. The number of pixels decides the resolution of a picture. The more the pixels, the better is the resolution. Students, to send the picture from point A to point B, we convert every single one of these pixels into its corresponding bit pattern. The bit patterns are then transmitted from point A to point B, and all of these bit patterns are converted into pixels, and therefore these pixels are then used to recreate the picture at the destination end. Students, then comes the audio. Audio is slightly different from text and numbers. Audio is continuous. Audio is not discrete like the bits. And therefore, audio is transmitted in a continuous pattern from point A to point B without converting into a bit pattern. Students, video can be continuous. So without conversion, we can transmit video as well. Or it can be discrete. If it, for example, if it consists of multiple pictures lumped together to form a video, if you introduce motion to that set of pictures, you come up with a video. So in the case of video, it can be continuous or it can be discrete. And depending upon that, we can either send it directly or we can convert it into a bit pattern and then transmit it. Students, these were the different forms of data, or how we represent different forms of data into a particular format that can be transmitted in a data communication system. Now, students, moving on, we'll talk a little bit about the data flow. Data flow means how the data flows from point A to point B. There are three basic modes that we are going to be talking about when we discuss the flow of data between the source and the destination. The simplex mode, the half duplex mode, and the full duplex mode. If you understand these three different modes, you will almost completely understand how the data is communicated in today's data communication system, whether we are talking about a small network or a big network, or we're talking about a local area or a wide area. Let's go to a slide and discuss these three modes in detail. Students, the first mode is the simplex mode. As you can see in the figure, the direction of data is unidirectional. It's only in one single direction. Think about it as a one-way road. Only one of the two devices can send the data on this road, and the other one listens. As you can see, the mainframe sends the information, sends the data to the monitor. The monitor will never send this data or any data back to the mainframe. Students, keyboards is an example. Keyboards are only used to send the data to the monitors. Keyboards never receive the data. So our direction of data from a keyboard to the monitor is simplex or is unidirectional. Similarly, students, you have got half duplex. As you can see, in the case of half duplex, each sender and receiver, each of the two machines, they can transmit and receive, but they can't do that at the same time. So they take turns. The full bandwidth from A to B can be used by each one of those machines, only one of those machines at one single time. So the first machine transmits or sends data at time 1 and then stops. And then machine number 2 sends this data at time 2 and then stops. Students, if you have heard of walkie-talkies, that's a good example of this kind of a data flow. Transmit your message, you say over, and then you allow the other party to communicate, and they do the same as well. Students, the last and the third form of data flow, or the mode of data flow, is full duplex. This is what we almost inadvertently use in every one of our communication systems these days. Students, both systems can transmit and receive simultaneously at the same time. The full duplex, think about it as a two-way street in which the traffic can go in both directions. And so both the machines, both the systems, they share this transmission medium by either having their separate transmission paths or by dividing the overall capacity of the link between them, the channel between them, into these two systems. So students, this particular mode is used when both directions need to transmit data to each other, when the communication is required to happen in both directions. So students, this is a little bit about the different modes that we have got for data flow and a little bit about data representation in a data communication system. Thank you very much.